Hey guys, Mr. Ye here, and today I wanted to talk about section 1.4 from our textbook, which deals with absolute value and absolute value equations. So, couple things. First off, absolute value is denoted by these vertical bars. They're not parentheses, they're not brackets. They are these two vertical bars that surround the x. We would pronounce that as the absolute value of x. It's just the absolute value of whatever's inside those vertical bars. And what is absolute value? Well, absolute value is the distance of a number from zero. So one thing to note here, because we're talking about distance, is that absolute value will be a positive number, or could be zero, because zero is 0 units from zero. But if we are looking at point A, right there on the number line, and you can see it's at 5. And so if I'm asking what is the absolute value of A, well, the absolute value of A is 5 because it's 5 units away from 0. What about the other side? What if we have the absolute value of B in this case? Well, the absolute value of B would be 3 because it's 3 units away from 0. Yes, it's on that negative side, but it is 3 units away from 0. Distances are positive or 0. They are non-negative, and so absolute value will always be non-negative. So kind of as we've seen here, the two examples that I just showed, absolute value of A is 5. Absolute value of B is 3 in this particular case. Absolute value, we could just put a number in there. Absolute value of -9 is 9. It just turns it positive if it was negative. And then absolute value of 0 is 0 because it's 0 units away from 0. So you see my note in italics there that absolute value is never negative because you can't have a negative distance. You would never say, I live -4 miles away from this place. No matter if you're north of it, south of it, east, west, it's always just, I live 4 miles from this place. So absolute value, never negative. So couple problems. One, the first type of problem is just going to be plugging in values and evaluating expressions that have absolute value in them. So for example, 2 plus the absolute value of 3x plus 1. So if we're told that x equals 2, then my first step is just going to be plug that 2 in for x. In fact, I'm going to make it a different color just to color code a little bit. X equals 2. So I'm going to put the 2 there. I'm just plugging that 2 in for x. And so that means we have 2 plus the absolute value. And one thing I should say is even though at the beginning of this video I said those absolute value bars are not parentheses, they still serve to group elements in the expression. And so when it comes to order of operations, we can treat them in that same precedence category as parentheses. We're still grouping those things together. So 3 times 2, we'll do the multiplication first, is 6 plus 1. So we have 2 plus the absolute value of 7. We know that the absolute value of 7 is 7, because 7 is 7 units away from 0. So this is just 2 plus 7, which equals 9. Second problem on the screen, almost exactly the same, except we're plugging -2 in. So the question is, we're plugging a negative number in, will this turn out the same? Because we said the absolute value just flipped the value of a number. Let's see. The sign of the number, I should say. It flips it positive if it was negative. If it was positive, it stays positive. So just to clarify. 2 plus the absolute value of -2 plus 1. So 2 plus, again, we'll go ahead and order of operations, do what's inside those absolute values first. So -6 plus 1 is going to be, I think I got room, yep. 2 plus the absolute value of -6 plus 1, -5. And what's the absolute value of -5? Well, it's 5 units away from 0. So this is 2 plus 5, which equals 7. So it didn't turn out the same because when we plugged in that -2, we had other things inside the absolute value. It didn't just turn to a 2 right away. It turned to -6 when we multiplied by the 3. Then we added 1, so it turned to -5. So always when we're doing these, we don't want to take any shortcuts. We don't want to assume. Just plug in that value and evaluate using your order of operations and the arithmetic you know. So the other thing that you're going to need to look at in this section is how do we solve absolute value equations? So for example, we have absolute value of x equals 8. So if we use the definition of absolute value, if you think about it, absolute value, we said, means distance from 0. So we're looking for any numbers whose distance from 0 is 8. And you might be able to think to yourself and just see what the answer is. You might say 8, that's 8 away from 0, but there's a second answer. -8 as well, that's also 8 units away from 0. So this first example of this type of problem is really just a proof of concept. It's just showing you why we have to set up our two cases, because it could be on the positive side of 0, it could be on the negative side of 0. So what I like to do is, you can see kind of the caption there, when solving, isolate the absolute value portion and then set up two cases. Isolate means get it by itself. So I'm getting the absolute value by itself. It started that way in this problem. Then I'm going to set up two cases. I'm going to say that whatever was inside the absolute value is equal to the right-hand side, just as it is. Or the other possibility is that whatever's inside the absolute value could equal negative the right-hand side. That's our negative case on the other side of 0. So negative whatever the right-hand side is. Now, in this very simple problem, because it was just x, we're done. X could equal 8, x could equal -8, just like we thought from our number line that we were talking through at the beginning. But we set up two cases, and most problems won't have x alone. We'll need to do a little bit more, just like this next one. So right here, we have 4x plus the absolute value of x minus 7 equals -3x plus 9. And so you also see a footnote at the bottom. You must check your answers. I'll talk about that here in just a second. But let's follow the advice at the top of the screen. When solving, isolate the absolute value portion and then set up two cases. So first thing that we got to do is get absolute value by itself. So I'm going to subtract 4x on both sides. So now that's gone. We got absolute value of x minus 7 is equal to -7x's now, combining those like terms, plus 9. We've isolated the absolute value portion. That part's done. So let's create our two cases, just like I talked through above. Whatever's inside the absolute value, so x minus 7, equals the normal right-hand side, -7x plus 9. And then what's our second case? Whatever's inside the absolute value, x minus 7, could equal negative the right-hand side. And notice that I put that negative out front and surrounded the right-hand side in parentheses. This is because negative the whole right-hand side, we're going to need to distribute that negative by what was over there. So I'm going to go back to red and just solve out red first. So maybe I'll add 7x, add 7x. I could add 7 to get rid of the 7. So we have x plus 7x, we have 8x equals 9 plus 7 is 16. So we have x equals 2, it looks like, for red. And then what about for blue? We have this extra step. We need to really quickly just distribute that negative. So x minus 7 equals negative 7x, so positive 7x, minus 9. Okay, I'm going to subtract x both sides. So that gets me 6x, and maybe I'll add the 9 at the same time. And so we get 2. 2 equals 6x, divide by 6. X equals I'm going to simplify that fraction, 2/6 to 1/3. So I have this note at the bottom, you must check your answers. Absolute value has the fun little quirk that we can do everything right. We can do all the arithmetic right. We can set up the process and solve it through and still get answers that don't work. These are called extraneous solutions. And so we always need to check our answers at the end. And how do we do this? Just by plugging in whatever we got. So in red, we got x equals 2. Let's plug that in and see if that works. I might actually do it over, no, I'll do it to the right. I got more room over there. So plugging in x equals 2. So 4 times 2, plugging it into the original, plus the absolute value of 2 minus 7, does it equal -3 times our x value, which we're saying is 2, plus 9. And so we're just going to simplify, and if they equal each other, then we know this works. We know that that is a valid solution. So 4 times 2 is 8, plus, we got to simplify what's inside there, -5. Does that equal, -3 times 2 is -6 plus 9. So does 8 plus absolute value of -5, so +5, does that equal -6 plus 9 is 3. 8 plus 5 is 13. 13 does not equal 3. This is an example of an extraneous solution. We worked hard, we found x equals 2, except it actually doesn't work. So I'm gonna throw that one away. Forget about that one. Let's try our other one, which was x equals 1/3. So I'll come over here. 4 times our x value, 1/3, plus absolute value of 1/3 minus 7. And we're curious, does that equal -3 times 1/3 plus 9? Let's check. Fractions, a little bit trickier to work with, so I'll remind you of a few things as we're going through this. When we're multiplying fractions, we could say this is 4/1. Anything without a denominator has that implicit denominator of 1. And when we're multiplying fractions, we're just going to multiply straight across. So 4 times 1 on top is 4. 1 times 3 on bottom is 3. So 4/3 plus absolute value. And I'm going to do a little bit of side work over here. I'm going to figure out what this 1/3 minus 7 is, just up here. You'll notice I wrote that 7 as 7/1. So if you remember, when we're adding or subtracting fractions, we do need a common denominator in order to carry out the addition or subtraction. So I'm looking at this and I'm going to say, let's multiply 7/1 by 3/3, because that then would give us a 3 on the bottom. So 1/3 minus 7 times 3 is 21. 1 times 3 is 3. 1/3 minus 21/3. And now we can subtract them. 1/3 minus 21/3 is -20/3. So that was just some side work I wanted to do. So -20/3 is what that simplifies to. And I'm checking to see, does that equal -3/1 times 1/3? We get -3 on top over 3 when we multiply straight across. So -3 times 3, or excuse me, -3 divided by 3. I'll write it out that way. I'll show every step. Make sure you don't get confused there. Plus 9. So let's keep going. 4/3 plus the absolute value of a negative number is just its positive equivalent. So plus 20/3. Does that equal -1 plus 9? So 24/3, they have a common denominator. Does that equal 8? And 24/3, we can see that does simplify to be 8. 24 divided by 3. 8 does equal 8. So this 1/3, x equals 1/3, that is a good, valid answer. It is not extraneous. X equals 1/3 is a solution to our problem, okay? So what I would like you to do is try this problem. Okay, I'm gonna pause the video, I'm gonna work it out. I want you to pause the video, work it out on your piece of paper, and then click play when you're ready to check to see if your answer was the same as I got. So let me pause the video. All right, I am back and I've worked out this problem. Hopefully you also took the opportunity to practice this. As you can see from my screen, I went ahead and made our two cases. Our absolute value was already isolated. So I made our two cases saying 2x plus 1 equals the right-hand side 4. And then I set up my blue case, which is 2x plus 1, whatever's inside the absolute value, equals negative the right-hand side, so negative 4. Went ahead and solved, I got x equals 3 halves and x equals negative 5 halves. Now I did make sure to check my answers, and right now I'm checking them by hand. I will be showing you guys another way to check them involving our graphing calculators that can be a little quicker, make life easy. But right now we're just checking these by hand, plugging in those values, see if we get a true statement. So on the left-hand side, you can see that when we plug in 3 halves, we do get 4 equals 4. That is a valid statement. And then on the right-hand side, when we plug in negative 5 halves into our original equation, we end up with 4 equals 4, which is also a true statement. So if you did not get what I got, pause the video, really look through my work, look through yours, see where we go different paths. Make sure that your check looks like mine, that you did check, and really just rewind, pause, do what you have to do until you can find whatever error was made and fix it, okay? One more problem, and it's on the screen right here. When solving, isolate the absolute value portion, set up two cases. We know that absolute value of 5x minus 4 plus 11 equals 9. So same thing. I want you to pause the video. I want you to write this down, try working it out. And then when you're ready, resume this video and I'll have my work on the screen. So I'm pausing now. All right, I am back. I've got my work on the screen. And as you can see, what I got was that this absolute value equation had no solution. And let me explain kind of what that means and what that looks like. You can see, first thing I did was subtract 11 on both sides to isolate the absolute value portion. I set up my two cases. I solved through and I got x equals 2/5 in red and x equals 6/5 in blue. When I went to check and plug them in, on the red-hand side, you can follow my arithmetic. Again, pause this video if something looks different from your work and my work. But on the left-hand side, I have 2/5 plugged in. I simplified fractions, whittled it down, and I got, does 13 equal 9? Which of course it doesn't. On the right-hand side, in blue, I had 5/1, 2/5, again, fractions and simplified it down. And again, I got, does 13 equal 9? Which the answer is still no. Answer is still no there, and so neither answer worked, which indicates a no solution. Now that is a possibility when working these problems out, and you actually might, some of you, have reasoned out in your head that there was no solution way before I did all this work. It's very possible to see from this line that I'm highlighting right now in yellow that there is no solution to this absolute value equation. And here's why. When we isolated the absolute value, we got absolute value of 5x minus 4 equals -2. Now stop there and think about that. What was one of the first things we said about absolute value? Absolute value is always non-negative. Could be 0, could be any positive number, but it's a distance. It's a distance from 0. And so when we get to this line in yellow that says absolute value of 5x minus 4 has to be -2, has to be a negative number, I mean, that's our cue that we can say, nope, that doesn't work, that doesn't cut it, and there is no solution. Now the good news is, even if you didn't realize that, if you didn't recognize that right away, you still got to the same result in the end. Did it take a little more time, a little more work? Absolutely. We solved it out. We had to do a lot of checking, arithmetic, but it's not essential that you recognize it right away, that the absolute value can't be negative. It's just a nice time saver and something that you can start keeping on the lookout for. So we had an example with no solution. We had an example with 2 solutions, also possible with absolute value equations. And then we had an example with 1 solution. And so just further proving the point, you have to check your answers. Even when you get them, you got to plug them back in and make sure that they work. So these are the types of problems that are representative of section 1.4 in our textbook, absolute value and absolute value equations. I hope this video helped. Guys, as you're watching these videos, at any time, one of the beauty of videos is you can pause, you can rewind, you can watch something again and again, listen to the explanation, and maybe that second time it clicks, maybe that third time it clicks. But you're doing what you need to do to really learn and understand this material. I'm here to help you as much as I can in any way. So let me know if you have questions, but make use of this video. I hope you got the opportunity to try these problems on your own. And when we meet again, we'll have a better understanding of this. So let me know if you have questions. And as always, I will see you next time. Bye.